Through his projects in northern India, specifically around the Shivalik Hills, and central India, based in the central Narmada Valley and Tapi basins, he's trying to understand human behavioral evolution, associated environmental adaptations, and technological transitions throughout the Quaternary. He's currently collaborating with various multidisciplinary specialists at international institutions in India, Germany, Israel, the USA, and Australia. In addition, he also has a collaborative field project in Sudan to investigate regional prehistoric records and possible evidence of hominin dispersals out of Africa. The speaker today will be talking on climate and cultures, quaternary environmental dynamics in human adaptations in India. So the abstract is available online on our Twitter handle, as well as it's circulated through our different WhatsApp groups. So you could always check up on the abstract then. A bunch of housekeeping rules. We are recording this lecture as well as streaming it live on YouTube. So I would request everybody to be mindful of that. Also ensure, especially those of you who are on Google Meet, that your audio is muted and your video is switched off. One, this ensures that the speaker during his presentation and talk is not disturbed. And two, whenever there are people who are organizing and attending this from areas with low network connectivity, they have enough bandwidth that it doesn't affect their experience and participation. I request everybody during the lecture to keep putting your questions both in the chat menu at Google Meet as well as on YouTube Live. We have a team of people who would curate these questions, and at the end of the talk, we would have a discussion based on these questions. I'll just check out if our speaker is available and he's logged in. I'd also like to give a shout out that this video will be available on YouTube later on, so you could also check out our YouTube page to see this and the previous lectures that have been in the series. And on that note, if Dr. Parth Chauhan is here and ready, I hand over the screen to him. Please, sir.
Hello?
Yes, sir, you're audible.
Okay, so thank you for the introduction and the opportunity to present. So I'll share my screen now. Can everyone see that?
It's 1 second, sir, it's loading.
The internet has been erratic today, so please bear with me.
No worries, sir. We understand that it's technology is beyond our control. Yes, sir. The screen is up. The presentation is ready, so you can take it away, sir. Thank you so much.
Okay. So basically, this is my topic: climates and cultures, quaternary environmental dynamics, and human adaptations in India. So I'll be basically giving a broad overview of what we know and what we don't know. And at the end of the talk, I'll summarize everything and separate into Pleistocene issues and Holocene issues. But I'm not trying to correlate specific cultures with specific environmental events, because the amount of data we have is not high resolution enough to actually talk about links between the various parameters. But I'll just give you examples of case studies.
Yes. That's what I sent it to Dr. Yadav also.
Links. So as we know, our story begins in Africa, and the oldest hominids are 7 million years old.
All the minutes can remain as it is. He can anyway send another email as an add-on.
1 second, sir. I'm so sorry for this.
Can you mute everybody?
Yes, sir. Dr. Shah, Dr. Santosh Shah, could you please mute everybody?
Manoj, please look to see that everybody is muted, because the sound is coming. Okay, Parth, please. Yeah.
Yeah.
Okay.
So we have at least 6 different genera reported and over 30 species reported from within Africa and outside of Africa. And if you look at the fossil evidence, it's very fragmentary. We are still working out the relationships between different species and trying to understand their environmental adaptations, not only during occupation, but during dispersals. So we have a very rich record of evidence in pockets, but not everywhere. So major geographic gaps and major chronological gaps, as you know. So to talk about dispersals from Africa, we have 3 sets of evidence. One is fossil evidence, another is artifactual evidence, and the third is genetic evidence. And the genetics is coming from, the DNA evidence is coming from modern populations as well as fossil hominins. But I'm just going to be just giving an outline here. Basically, we have the earliest technologies starting at 3.3 million, and then they changed over time, and they continue to evolve. And from the Acheulean onwards, roughly 1.7 million onwards, we have technologies getting smaller. So we have Oldowan and Lamequian in the beginning. And then from 2.6 million onwards, the technologies are continuous. But between 3.3 and 2.6 million, at the moment, we have no archaeological evidence. Now, on the right, I have dates for dispersals. And on the left, I have dates of invention. So you can see soon after invention at 2.6 million, the Oldowan gets to Eastern China by 2.1 million. So each date is correlated with a dispersal. But if you look at the column on the right, the colors in blue pertain to India or the Indian subcontinent. And we have Acheulean, basically, the oldest outside of Africa is currently in India. And that record is between 1.5 million and ending at roughly 120,000. It's not exactly clear, but this is based on current evidence. And then we have more than one Acheulean dispersal happening. And then we have Middle Paleolithic emerging. Now, it's possible that Middle Paleolithic has possibly multiple origins or multiple locations of origins instead of one single origin in Africa and then rapid dispersals everywhere. So the Indian evidence, again, is spread out from 385,000 to 38,000. And then we have various Upper Paleolithic assemblages. And then microliths appear in the subcontinent at 48,000 and onwards. And there's a rapid dispersal soon after. So all of these technologies are associated with different environmental parameters, different hominin species, different types of adaptations, and of course, different biogeographic routes taken from Africa and into Eurasia. The question is, which hominins were responsible for which technologies, and why is there sometimes parallel evolution of some technologies while there's only single origin of other technologies? So we're trying to work this out, and we have a lot of potential for the Indian evidence. Now, just to highlight the Indian subcontinent, why is it important for paleoanthropology or human origin studies? First of all, it's in the center of the old world. So it geographically links all the records from Africa, Europe, Asia, and various surrounding regions. And also, it represents the easternmost occurrence of rich and classic Acheulean. There's a continuous evidence of continuous occupation from 1.5 million onwards, and maybe this might get extended to 2 million or 2.6 million. But we don't know if there's how many gaps are there in between. We also have the Shivalics, which are one of the best studied fluvioterrestrial sequences in the world, from 18 million years onwards. We have a very lengthy history, at least the similar history, 18 million year history of monsoon existing in the region. We have a very unique vertebrate fauna record. Many of the mammals found in the subcontinent are not found elsewhere, and vice versa. And we have the largest source of terrestrial deposits of the younger Toba tephra, which is about 74,000 years old. And we have a handful of dates, but not very clear. We have thousands of sites known, Paleolithic sites, but now we just have very few dates coming up. The older dates done in the 70s and 80s are not very reliable, especially the uranium thorium. And now new luminescence techniques are being applied. And of course, cosmogenic has been applied. So there's now a lot of potential for redating some of the known sites as well as new sites. But still, compared to African projects, European projects, even Chinese projects, we have very few dates available. So we're not able to correlate arrival of different hominins and changes in different technologies over time. But these are just broad indications of what we have so far. And of course, as many of you know, we don't have that many hominin fossils. The most abundant evidence belongs to Homo sapiens, and the oldest being the Sri Lankan evidence. So that's about 40,000 years old, but everything else in India is younger. The only pre-sapien fossil we have is belonging to the Hathnora specimen and maybe other postcranial elements found in the region. But what is happening is because we have a lack of focused surveys, a lack of experts in hominin fossils, and of course, sometimes the lack of right context and right preservation conditions for fossil preservation. So these are various factors explaining the lack of hominin fossils compared to other regions. And if you look at the earliest evidence out of Africa, this is now showing different ages. For example, 2.1 million years ago, they reach eastern China. So we have evidence of mode 1 technology or something like Oldowan reaching very early. We don't know exactly when they left Africa, in which species was involved, but we have clear evidence that it was definitely long before 2.1 million. And then we have younger evidence in Southeast Asia. We have evidence from Dmanisi in Europe, pointing to about 1.8 million and 1.5 million, and then younger sites. So there must be sites older than 2.1 between Africa and Eastern China. And what role does India have to play in this is very critical. At the moment, evidence for this dispersal in the subcontinent is very, very sparse and very, very ambiguous. For example, the British Archaeological Mission to Pakistan in the 80s reported artifacts from Rivat and Pabi Hills in Pakistan. And these are about 2 million years old. And the Pabi Hills material is from 2.2 to 1 million years old. But most recently, a French Indo project reported basically cut marks from a fossil near Chandigarh at the site of Masol. Now, there are several issues with all of these sites. First of all, none of the sites come from well-excavated or well-dated context in anywhere in the Shivalik zone, and I'll talk about that separately, the geographic dichotomy. The cut marks reported from Masol could have been made through other processes, so they're not unequivocal. They're not really guaranteed that they're made by hominins. But if they're made by hominins, it could suggest a very early dispersal at 2.6 million or slightly younger. But again, we need more evidence coming from excavations in association of fossils and artifacts together in the same context. But we do have paleo-environmental reconstructions. For example, researchers such as Patnaik and others have reconstructed habitats based on fauna, for example. So it shows that these pockets in the Shivaliks had specific environments like grasslands, lake environments, floodplains, riverine environments, suggesting very conducive habitats for hominin occupation, especially across the entire Pinjore Formation. And this is supported by recent isotopic evidence, again suggesting changes and fluctuations between forest environments and grassland environments by different fauna. Now, if you compare this evidence, the Shivalik fauna, with other zones, for example, we get a better understanding of the nature of the habitats. For example, this compilation by Patnaik and Nanda shows that there's a lot of ecological similarity between the sites of Dmanisi, Ubadia, the Southeast Asian erectus sites, and the Pinjore Formation of India and Pakistan. This shows basically similar fauna, reflecting similar ecologies across these zones. So Europe, Levant, India, Southeast Asia, all share similar ecologies in different pockets. But the first three localities have yielded hominin fossils. So far, no convincing hominin fossil material has been reported from the Shivaliks. However, this shows that there's potential. There's potential for finding evidence and maybe even preservation. Now, some have tried to explain the presence of artifacts, but the absence of hominin fossils. If you have 2 million-year-old artifacts, why don't we have hominin fossils in the Shivaliks, even though we have abundant fauna? So one explanation is possibly taphonomy. For example, in a case study in the Pabi Hills, a specific size of mammals have been well preserved. So you have large mammals and medium-sized mammals abundant, but you have small to medium-sized mammals very rare. So that might also explain the lack of hominin fossils preservation in the Pabi Hills. But we cannot apply taphonomic patterns in one location or from one study across the entire Shivaliks. Each zone of the Shivalik ranges needs to be looked at independently. So this is just one example of why we might not be finding hominin fossils where artifacts are abundant. Another big problem we have in the subcontinent is the dichotomy I was talking about. The geographic dichotomy between the Shivalik Hills and the rest of the subcontinent. We have extensive early Pleistocene deposits in the Shivalik range, of course. The problem is they're uplifted, they're hard to access, they're not very well defined or well dated, even though the fauna is suggesting a similar conducive ecology. But if you look at the rest of the subcontinent, central India, peninsular India, and parts of Pakistan and Nepal, we don't have that many early Pleistocene contexts. So this can explain one reason why we're not finding that many early Pleistocene fossils, but also why it's hard to find early Pleistocene archaeological sites. So it's not that hominins were not around, but it's possibly because of either they're not well defined or not properly identified, or in some places they're deeply buried. And of course, we might have come across early Pleistocene context, such as these sites here, for example, Singitalav, Dasi, Chirki, Morgaon. These have been dated by paleomagnetic method. But Atirampakkam has been dated by paleomag as well as cosmogenic. So it's one of the only sites that has an absolute age. The rest of the sites is all relative chronology. So we need to identify more sites actually with early Pleistocene context to understand the distribution pattern of hominins and possibly fauna as well. So you can see a big dichotomy in across the Pan-Indian zone. Now, if you come to the next technology, the Acheulean, we have abundant evidence in Africa, Europe, Arabia, Levant, and all the way up to India. See, this gray area is made the main domain of the Acheulean. But beyond that, we have not reported that many Acheulean sites. Now, in the last 10 years or so, 15 years, more and more biface sites are coming up. These kind of sites in the eastern zone, in China and Korea. Now, the oldest evidence is about 800,000 years old from Boza, South China, but everything else so far seems to be younger. Earlier, the question was, why aren't Acheulean sites found in the eastern zone? But now the new question is, are these Handak sites or biface sites Acheulean? Do they represent an Acheulean dispersal from the west, or do they represent independent innovation? So one solution that we need is basically evidence in the intermediate zones, whether there was dispersals from west to east, and also what role did India have to play in this, or maybe did not have a role to play. It's possible that they took a Central Asian route of dispersal, but did not go across India and into Southeast Asia. We need a lot more research, a lot more many sites to compare, to date, and to understand the connections, if any. But at the moment, the Acheulean technology, in terms of its classic sense, appears to end in India. So, for example, the earliest evidence is coming from Atirampakkam, a very well-known site, studied for a century and a half now by different researchers. And Shanti Papu and her team have identified early Acheulean layers as well as early Middle Paleolithic layers at the site in roughly a 6-meter sequence, sedimentary sequence. It has also yielded possible animal footprints and shows a very minimally disturbed, low energy primary context, which is ideal for understanding technological change as well as environmental adaptations. And this is also one of the few sites where they've actually directly applied paleoenvironmental reconstructions. For example, phytolith evidence, as well as the rock magnetic records, show changes in vegetation and changes in rainfall patterns. Now, unlike other sites where we have work done independently or mutually exclusive, this is one of the rare occurrences where we have reconstructions of quaternary environments at the archaeological sites or within the archaeological layers. Most other evidence comes from indirect interpretations or regional environmental evidence or indirect evidence of environmental change, for example. Now, looking at Acheulean sites elsewhere, for example, in Western Zone, Deo and colleagues did a study based on sedimentary context. So what they did is they looked at the association of different types of sediments with Acheulean artifacts, particularly early Acheulean, and tried to identify humid and arid or semi-arid contexts. So this again shows another way when specific methods are not possible to apply always, or the dating is difficult, we can actually use stratigraphy, different types of sediments, and the archaeology, if it's coming from secure context, to talk about technology and links with a specific habitat or a specific environment, especially if there's vertebrate fossils associated also. So this is just a broad attempt at trying to correlate specific adaptations in a specific zone with Acheulean technology. They again compiled the same for other sites. So based on sedimentary evidence, they tried to associate these various sites like Patpara, Bamburi from Son Valley, and then Sadab, Hunsgi, Tegihali, and Kaldemanhalli, and the Yadurwadi from South India into semi-arid environments or arid environments or humid environments. Now this again is preliminary work, and we need more detailed research of high resolution. For example, if possible, stable isotopes evidence, vertebrate faunal evidence. But until we have that, we need to use this kind of indirect evidence to build up the complete picture, because all zones are not going to have very good preservation like Atinampaka. Now, why is India a cul-de-sac? What is the reason why technologies are not going eastwards? Because at the moment, we have no Acheulean connection between India and Southeast Asia at the moment, nothing proven. No connections between the Indian Lavalva or Eastern Asian Mousterian or Lavalva technologies. And the same thing with early Microlithic and Upper Paleolithic. In fact, a lot of these technologies don't even seem to reach the northeastern zone. So it's not clear what's happening. Why is it ending up earlier? Why are these technologies ending up in India and not continuing onwards? So in some ways, we have some environmental, geographic, topographic, and climatic barriers in these zones. For example, Acheulean technologies are not found in tropical areas, such as Kerala, extreme south of Tamil Nadu, Sri Lanka, northeast India, because they were more adapted to grassland environment, more open environments. So maybe it's possible that they avoided these zones. But then we also have the Tibetan Plateau, where the oldest evidence is about 130,000 years old, so a post-date the Acheulean. Then we have the Himalaya as a barrier, and then we have the Ganga Plains, which might have been a barrier in a way because of the lack of rocks. It might have been avoided largely because of thick sequences of alluvium and lack of rocks to make artifacts. And then, of course, we have the eastern zone, Burma, and surrounding areas like Laos, Thailand, which are not similar habitats as compared to the main Acheulean domain. But it's possible that populations abandoned Acheulean technology and adapted to a different technology. It's not necessary that just because the technology did not continue, the population did not continue. Now, what's happening in the Middle Pleistocene after the Acheulean? There's changes again. This is a recent paper by Au et al. And they've talked about basically warmer interglacial conditions at around 400,000 years ago and higher sea levels at a global level. And they have tried to integrate this evidence with appearance or diversification of the genus Homo into different species across the old world, as well as the emergence of different technologies. So for example, appearance of Homo sapiens in Africa, appearance of Homo neanderthalensis in Europe, then erectus is still around. We have Homo naledi in South Africa. So you have various hominid species across the old world, which are very contemporary with each other before they become extinct, and then leaving only Homo sapiens after about 30,000. And then we also have Homo floresiensis in Southeast Asia, mostly living in isolation. So now what they're trying to say is that there's a link between these warmer interglacial conditions and the transition from Acheulean to the Middle Paleolithic, or from the Lower Paleolithic to the Middle Paleolithic, and the emergence of Levallois technologies. Again, this is just a broad correlation. It's not clear if all these factors were affecting this technological change in all regions or in particular regions. What is interesting is that Seri et al., Seri and colleagues, have also hypothesized that Homo sapiens is not appearing in Africa from one single source. It's possibly appearing from multi-regional evolution or multiple populations at the same time across Africa. So we need to see if these environmental conditions are always linked with speciation events or new technological innovations or other factors that are responsible. This is a big problem of trying to link these things always, especially the further back you go in time. But what is interesting is, even though this is not proven at the moment, this is just a hypothesis, what is interesting is that this transition from the Lower Paleolithic to the Middle Paleolithic seems to occur at the same time everywhere. So Au et al., they offer this figure showing hominid technologies contemporary with each other. You can see, after about 400,000, we have Homo naledi, archaic sapiens, Homo sapiens, Neanderthals, and Denisovans, erectus, and other species contemporary. But the technologies, there's only one dichotomy. The hand axes basically disappear and are replaced by points and flipped tools. And of course, blade. So we have major change in technology happening. Now, what is unique is this technological change and biological change is happening globally, all across the old world. In Africa, Europe, Levant, India, and maybe Central Asia as well. New hominins are emerging, like Homo sapiens in Africa, the Neanderthals in Europe, and we don't know what is happening in India because we have no fossils. But technological change, for example, at Atinampakam again, we have the Middle Paleolithic emerging around 400,000 to 385,000 years ago. So that shows that it's not a result of dispersal from Africa. Middle Paleolithic technologies are emerging at different locations at the same time, possibly. Then we have this kind of specimen like Dali specimen in China, resembling other specimens, despite the vast landmass separation. So what's happening with Homo sapiens? Once Homo sapien emerges around 300,000 years ago, it starts to disperse rapidly. The earliest evidence we have at the moment of Homo sapiens outside of Africa is about 200,000 years ago in Greece. Then another fossil in Levant, 177,000 years old. Then younger fossils in China. Then younger fossils in Sumatra, and then archaeological evidence in Australia. But what's happening in India, we don't know this because of the lack of fossil evidence. It's possible that they took Central Asian route as well as the Indian route to get to Eastern and Southeastern Asia. We need more fossils to prove this. But what we know now, compared to the last 20 years, is that there were multiple dispersals of Homo sapiens out of Africa. And each time they reached different locations. Some of them were successful, some were unsuccessful, some had Middle Paleolithic technology, some took bifaces with them, some took microliths with them. At different points in time, different technologies were adopted, and there were different adaptations to different environments, depending on the route they took. For India, what is happening, the fossil evidence is clear that they were there 40,000 years ago. And the genetic evidence on modern hunter-gatherers shows they were definitely there 60,000 years ago. Means a continuous occupation the last 60,000 years, because we have mutation rates showing this. So they arrived around 60,000, and there was continuous occupation into modern day times. But it's possible they could have reached earlier, but they just didn't survive. So the genes didn't get passed on. So we're looking at least 2 dispersals maybe of Homo sapiens into the region. This is currently debated. So one debate is they came for the first time around 60,000 with microlithic technology. Another team says they came much earlier, maybe early as 77,000, and now recently they've reported 115,000-year-old artifacts from Gujarat, from Kutch, again linking that with Homo sapiens. So if that's true, that shows a very early dispersal of Homo sapiens, but not a continuous occupation. Maybe there was small populations coming in, and then later on, they're coming in large numbers and spreading rapidly. So you could have 2 different populations of Homo sapiens coming in at different times with 2 different technologies. But what is making this complicated? Why isn't it so simple? The reason is because we have now an older Middle Paleolithic from Adirampakkam. If this belongs to some archaic species before the arrival of Homo sapiens, it is possible that the younger evidence also belongs to an archaic species. Maybe the younger Middle Paleolithic is also not belonging to Homo sapiens. Or maybe it's possible that the earlier evidence belongs to an archaic species, but the younger evidence was brought in by Homo sapiens. It is possible that the same technology was used by different species in different locations. And in some cases, we have found evidence where we have the same species using different technologies across the landscape. And between this time, we have large bifaces and small bifaces appearing and disappearing. And it's probably related to different habitats, different subsistence strategies, and different adaptations. Now, a big debate for this time period. So what I'm doing is I'm going in chronological order, from oldest evidence to youngest evidence. There's been a big debate for the last couple of decades about the impact of the Toba super eruption on hominid populations and technologies. Now, there's basically a debate going on whether there was minimal impact or a major impact on the ecology, and whether that led to changes in tool technology. First, this evidence was reported from Jwalapuram in Andhra Pradesh, and that's where they reported artifacts from 77,000 years to 38,000 years, Middle Paleolithic continuing. That was the first hint that possibly the populations were persistent and they were not affected by the super eruption. Now, a new study by Clarkson and colleagues again suggests that there was a continuity of Middle Paleolithic technology across the eruption, essentially between 80,000 and 65,000. Now, one issue is that we need more sites. This evidence is not enough. We need to look at more sites across the subcontinent in different environments, because most probably the impact was variable across the landscape compared to Western India, Central India, Eastern India, South India. So we need to look at it from a geographic perspective. This might show that they were not affected in this area, but they could have been more affected and the technology might have changed in a different location. So this is just a preliminary perspective in the Son Valley. So it shows technological continuity between these age ranges, but whether these technologies belong to Homo sapiens is a different matter. It is possible they belong to Homo sapiens, but we need fossil evidence. At the moment, we don't have any going back this far. And another problem with identifying species from stone tool technologies is that we have a diversity of stone tools across the subcontinent, especially after 100,000 years and onwards. We have, at some places, we have Middle Paleolithic with bifaces, we have Middle Paleolithic without bifaces, we have Upper Paleolithic technologies, we have microlithic technologies, sometimes overlapping with each other, spatially, contextually, geographically, chronologically. So we need to understand what is the reason for this diversity. Is it only ecological changes, or is it because of different adaptations, or different subsistence strategies, or different hominid species coming and going? Or is it possible that the same species were using different technologies in different ecozones? Sometimes there's going to be raw material constraints also. If the rocks are not suitable, then specific technologies would not be expected. They wouldn't be able to make them. But why we don't have diagnostic technologies in the northeastern zone is a mystery. We need more research in the northeastern zone, in fact. And then we come to another proxy for environmental reconstructions is vertebrate fossil record. At the moment, as you can see from the map, we have distribution of fauna, Pleistocene fauna in the Shivaliks. We have abundant evidence in Ganga Plains, Son Valley, Narmada Valley, Godavari, many fluvial basins, basically. The problem is that we don't have any dates for these fauna, very few dates. And whatever dates we have are very young. So we have cases where we have older fauna possibly often redeposited into younger context. So we need to understand that just because we're finding abundant fauna in late Pleistocene context doesn't mean they're late Pleistocene age. And because of lack of dates, we don't have any first appearance datums or last appearance datums for these fauna. And we're not able to correlate or link these fauna with the better dated Shivalik fauna. What exactly happened after the early Pleistocene? So we have a lot of fauna in late Pleistocene context all over India. We have a lot of fauna in early Pleistocene context in the Shivaliks, but we have no fauna in well-dated middle Pleistocene context. Either the contexts have not been dated because of dating limitations, or there's no faunal preservation in middle Pleistocene context. There's some kind of taphonomic bias, so there's also a research bias, there's also preservation bias going on. So we need to see what's exactly going on. But we can use this fauna, we can try to date it directly by radiocarbon, by AMS, by ESR, uranium series, and if we are successful with the dates, then we can proceed with stable isotope evidence to understand environmental reconstructions. But at the moment, we have a lot of fauna. So compared to in this map, if you look at the Indian subcontinent, they're dominated by late Pleistocene sites. Early Pleistocene is very rare. Middle Pleistocene is very rare. So we're not able to link or correlate these fauna with other zones in the old world. But we do know that there were specific biogeographic corridors in different locations. And we do know that there's a continuity of Indian fauna for at least the last 200,000 years, as Roberts and colleagues have demonstrated in their PNAS paper, in their review of the fauna and looking at the modern Indian fauna and the fossil fauna. But again, we did a lot of research on this fauna. And most importantly, we have to understand the relationship between the fauna and the hominins. Did some of those species become extinct because of hominins? What were the changes in subsistence strategies over time? Because we don't have any butchery evidence yet, very clear and very convincing. For example, some has been reported from Isampur at Ashwin site in South India, and now Masol at 2.6 million in Shivaliks. But again, it's very preliminary and it's not unequivocal. But from the fauna, we know that they're adapting to different environments. So just like I showed you the faunal list earlier for different sites, we have good control on different types of fauna, but not all the fauna. So based on the micromammals, we know because they speciate and become extinct very fast. So we have a good idea of what's happening with the specific pockets in time and specific geographic locations. But we don't have a good understanding of all the fauna because we have sometimes preservation bias, or the fauna is not well dated. We don't know if it's out of context in many times. It's getting embedded into a younger context. So we need to work this out to see where all the species kind of correlate and whether they represent warm habitats, cooler habitats, how they correlate with the changing glacial and interglacial cycles. A major issue has been basically two things. One is extinction of species, but also geographic marginalization of species. So in this case, for example, hippos, they were prevalent and widespread everywhere in the Pleistocene, but then gradually they become marginalized and they're only found in pockets. And then eventually, around terminal Pleistocene or early Holocene, they become extinct. No evidence of butchery has been found, Stone Age butchery. So we have no clear indication of the causes of extinction. It's possible that there were already climatic changes happening that led to a shrinking of water bodies, for example, and the hippos could not disperse fast enough or adapt fast enough, so they died out. But it's also possible that as ecologies were changing in the terminal Pleistocene, hominin populations were moving around with microlithic technology. Sometimes maybe they were hunting fauna, but of course they were encroaching on habitats. So encroachment of habitats can also lead to migration of animals and eventually extinction. So it's not necessary there has to be a predator-prey relationship on all of these species to explain the extinctions. But the youngest dated fossil is about 15,000 years old. So from Narmada Valley. So this shows that it stopped occurring at the Pleistocene-Holocene boundary based on fossil evidence and archaeological evidence. The same thing with the ostrich. Ostriches are occurring in India from about 65,000 years onwards. And around the end of the Pleistocene, they're extinct as well. So it's not clear, first of all, the reasons for extinction, but we do know that there's an overlap between microlithic sites and the ostrich eggshell sites. So the dispersal could have been synchronous. Microlithic technology, Homo sapiens, and ostriches could have been all overlapping and kind of ecological overlap and a dispersal event as well. But it needs to be confirmed from more research. But most of these sites are located in arid zones. But then there's widespread dispersal of microlithic technology. But what's happening to the ostriches is that they're possibly becoming extinct because of human interference. We have evidence of ostrich eggshell beads, this engraved specimen from Patna. We have evidence of probably as a food source, maybe. We also possibly thinking they were used as containers. So if the eggs were targeted increasingly in the late Pleistocene, then it's possibly affecting the survival of the ostrich. They dispersed, they entered India, according to Blinkhorn and colleagues, they entered India during an arid environment. And then later on, once these corridors, ecological corridors change over time, especially MIS 4 and 3, there's a decline in ostrich populations. And then gradually, at the terminal Pleistocene and early Holocene boundary, you start finding ostrich eggshells. So it coincides with the extinction of the hippo, which is interesting because hippos are also found, they were earlier found in the same areas as ostriches, overlapping sometimes. So at the moment, without dates, all we can do is look at frequency of different species in different environments. For example, looking at gazelle, looking at nilgai, looking at deer, elephant species, different mammals, all we can look at is presence and absence and try to understand whether they were occurring widespread or they were actually disappearing. At the moment, we only have stratigraphy to rely on until we have dates. So if they're consistently disappearing in a specific stratigraphic layer across a large zone, then maybe we can say that they were becoming extinct. But we don't have enough information. But the fauna can still be useful to talk about habitats. So we need to eventually look at, this is an example coming from Southeast Asia, where we need to work relationships of environment, fauna, and possibly humans over time. What's happening basically over time across the different glacial and interglacial cycles? Which fauna are dying out? Which fauna are dispersing? Which fauna are becoming overhunted by hominins? And what is exactly the correlation between all of these things? This needs to be worked out for the subcontinent. And we have not exhausted faunal evidence. New surveys are yielding new species. So it's not that the fauna we know now is still exhausted now, and we cannot find any more species, even within central India and peninsular India. For example, we have these kind of herbivores still being reported. And that kind of evidence is showing that there was a correlation between the fauna and the local ecology. So Costa showed that there is change in the local habitat over time. So between MIS 5 and MIS 4, there's changes in sea level fluctuations, giving the fauna a corridor for movement and habitation, and this has indirect repercussions for hominin occupation as well. So we can try to correlate the presence of fauna, the type of habitat, and the type of technologies until we have absolute dates. And then we have broad ages based on changing sedimentary conditions, and of course, habitat reconstruction based on different types of fauna. And this has been done successfully at various locations. But the problem is, it's not clear whether some of them are secondary context, some of them represent a mixing of artifacts and fossils. So what are the different potential factors we need to understand? Whether it's only human element, whether it's natural deaths, or whether it's also environmental events like droughts, flash floods, then there's overhunting by prehistoric hominins, unsuccessful adaptations, especially in times of rapid environmental change. Maybe the hominins could not adapt fast enough, or the mammals could not adapt fast enough. So there are all these things reflected in the paleoanthropological evidence. We also need to see if there's taxonomic bias or preservation bias in some cases. And of course, terrestrial geomorphology and fluvial action responsible for these accumulations. It's not necessary that it's always going to be overhunting or it's going to be drought. It's going to be actually a range of factors in any given area. So the thing is, now I'm coming to the end of my talk, and just to show you that based on compilation of environmental reconstructions done in the late Pleistocene context, we have very few studies done. Early Pleistocene, of course, we don't have the context or the dating. Middle Pleistocene, same thing. We don't have the dated context to reconstruct habitats, but the most abundant work has been done for late Pleistocene context, and they include a range of proxies, including stable isotopes, fauna, Auschwitz eggshell evidence is there, so speleothems from caves. So some sites have used multi-proxies, but basically what the problem is here is that there's major geographic gaps, number one. Number two, some of the studies are not high resolution enough. And number three, these studies, the majority are exclusive of human occupation. They're not related to human occupation. There's very, very few studies which link local archaeological evidence with changing environments. This is one example by Ja and colleagues. In the Belan Valley, they look at changes over time in relation to Paleolithic transitions and Neolithic occupations. They're trying to correlate basically using multi-proxy evidence to talk about climatic change and possibly change in population dynamics over time and culture change. Now, it's not always possible to identify incoming dispersals versus indigenous innovations, but we can actually link these things at least to explain that change happened or did not happen. What the factors for change were is a different matter. Now, some years back, there was a hypothesis offered that environmental deterioration led to microlithic innovation around 35,000 years ago. But this is an old study, about 10 years old now. But now we have new evidence. So it shows that there is no pan-Indian evidence of such environmental change, number one. Second thing is that the microlithic technology goes back to 48,000. So it's not that there was innovation. Whether there was innovation or dispersal is a different matter. But we do know that there was no innovation at 35,000 because microliths appear much, much earlier. So we need to see technological change from regional levels. We cannot look at a pan-Indian perspective just from one site or one valley. We need to look at Thar Desert separately. We need to look at Narmada Valley separately. We need to look at the Northeast Indian zone separately, the Himalayan zones separately. So we need to look at it from a regional perspective and not apply preliminary results from one location at a pan-Indian level. And then a couple of studies recently from Sri Lanka show that hominins, especially Homo sapiens, were adapted to rainforest environments. Now, whether this shows inland entry from India or coastal dispersal is not clear. But it does show around 40,000 years ago, they were adapted to rainforest environments. And this has implications for Northeast India also, similar habitats. Same thing in Eastern India, in Orissa, we have microliths and fauna associated with LGM, terminal LGM. So I'm just showing you examples of correlating artifacts, fauna, and environmental proxies. The thing is that we cannot use this evidence to generalize about the Indian subcontinent because these studies are too isolated. And then coming to the Harappans, we have a long history of debate on the decline of the Harappans, but two recent studies show that, first of all, not all Harappan populations dependent on rivers. In some cases, it depended on springs, for example, or other water sources. And in some cases, the rivers were existing even before Harappan occupation took place. And there's new studies, for example, by Sarkar and colleagues, showing that there was a decline of the population, not only because of climate, but because of changes in subsistence patterns, or rather changes in farming strategies. So we need to now look at these issues and problems from a holistic perspective as well as a multi-aspect perspective. We cannot assign one major factor to these events. Decline of Harappans, also keep in mind, that was a huge area. So the way Harappans declined in the Indus Valley would be different from the way they declined in Kutch, in Saurashtra, in Punjab, Haryana, and other places. Different regional factors must have affected different Harappan populations over time. But at a broad level, is climate as well as changes in subsistence patterns. And same thing with Kutch. This study by Das and colleagues is showing that there were sea level fluctuations happening during Harappan occupation. So that could have also affected their long-term structure of the sites and how they're fluctuating in terms of occupation and abandonment of the sites. So sea level fluctuations is going to affect cultural layers for archaeologists. But I would like to emphasize that we have to go beyond the Harappans. There were other contemporary cultures in the Holocene. We have painted Guerrero culture in the north. We have other Chalcolithic cultures across India. Then we have Neolithic cultures, megalithic cultures, microlithic cultures, all contemporary at some places. So we need to look at a pan-Indian level and try to understand whether, for example, the mid-Holocene arid event affected these cultures also, or only the Harappans, because all of these had different subsistence strategies. Maybe some of them relied more on hunting and less on agriculture. Maybe some relied more on agriculture, so they were impacted more by the mid-Holocene aridification, known as a Mongolian event. So we need to look at all of these cultures from a regional perspective and looking at it from different factors, not just global events or events at the pan-Indian level. But this also shows that a lot of research has been done, which is mutually exclusive of the archaeological sites and the geological sites. We need to apply more geological methods to the archaeological sites. Only then we can get a clear picture of what's happening at a regional level. The same thing with the absence of Neolithic in some places. So we have uneven transitions in the Holocene. For example, in northern India and eastern India and southern India, we have a transition from Mesolithic to Neolithic. But in western India and central India, we have a transition from Mesolithic straight to Chalcolithic. In these zones, the Neolithic is absent. What is the reason? Is it only because of human population dynamics or cultural dispersals, or is it because a combination of environmental factors as well? We need to understand all of these things from multiple aspects. For example, Thar Desert, we would not expect Neolithic because of lack of vegetation, but other places like central India, we should see why the Neolithic transition did not occur. So just to conclude and summarize my points, basically for Pleistocene, we have a dichotomy between the Shivalik hills and the rest of the subcontinent. So early Pleistocene and lack of early Pleistocene. Absence of Oldowan evidence. We don't know when the first populations arrived. Was it before the Acheulean, or was it the Acheulean only? And why is there lengthy persistence of Acheulean bifaces, but a lack of dispersals into Northeast India? It's not just out of India, but why don't they reach Northeast India? What is the barrier? Is it the Brahmaputra Delta? Is it Ganga Plains? Is it something else? And what are the environmental factors for the different technological transitions? At the moment, we don't have any patterns. We don't have enough studies to talk about patterns of the change from hand axes to La Valva, from La Valva to blades, from blades to microliths, and so on and so forth. We still don't know the full ecological impact of the Toba super eruption because we have hardly any sites with primary ash deposits and artifacts. We need to find primary sites with artifacts below and above the ash. At the moment, we hardly have any such sites. And we need to see if there's really a link between ostriches, arrival of ostriches, and the arrival of microlith technology with Homo sapiens. And also try to understand what led to dispersals within the subcontinent after they appear. Once they enter the region, do they use coastal routes? Do they use terrestrial routes? Do they use the fluvial basins? Or do they disperse everywhere? What were the causes of extinctions and speciations of specific fauna? For example, hippo, ostrich, and then, for example, animals like the rhinoceros is now marginalized to Northeast India. And we need to see that, we need to make sure that we apply these proxies at prehistoric sites or archaeological sites directly. Most of these studies have been done at independent geological sites. So we can't really always reliably correlate that evidence with archaeological evidence, even if it's in the same valley, even if it's in the same zone. We need to do it more explicitly, targeting the cultural layers directly. And we also need to see how we can preserve key quaternary sites. This is a major problem because of development and other factors, erosion. A lot of the type sites are getting destroyed. And a lot of these sites have not been studied because new techniques are getting developed. So we need to apply those techniques, not just now, but in the future. So we need to find a way of how we can actually preserve some of these type sections because they're going to disappear if not preserved. Either preserve them at the site or preserve them somehow in the lab. We need to find a way, how we can do that. And finally, to end, I'll summarize this Holocene studies. What were the factors of extinction for hippo and ostrich? Because they go extinct at that boundary, Pleistocene Holocene boundary. And what was the reason for the regionalization of some species like rhino and lion? Was it because of hunter-gatherers, or was it because of ecological and climatic changes? And what impact did hominins have on the landscape? And not just the Holocene, but before that. Even in the late Pleistocene, Mesolithic populations, maybe upper Paleolithic populations, were burning vegetation maybe. We need to see if that was happening, first of all. And second of all, how was it having an impact? There could have been extensive use of fire, then agricultural activities like slash and burn, clearing large patches of forest, which is very common in Neolithic onwards, and of course, faunal overkill. So how did impact on the ecology and impact on the animal life affect the landscape? How did these things affect the environment over time? When did hominins start making a noticeable change on the landscape? And we also need to understand what were the reasons behind uneven regional transitions. As I said, some places it's going from Mesolithic to Chalcolithic, and some places from Neolithic to Chalcolithic. Certain technologies, in fact, throughout the prehistoric period, are absent in many regions. What is the reason for their absence? Like, why is Acheulean absent in Kerala, for example, in Northeast India? And why is La Valva only found in certain pockets? Why are projectile points showing evidence of spears found only in certain pockets? Is it because of fauna? Is it because of culture? What is the reason? And we need to go beyond Harappans. We need to look at microlithic producing hunter-gatherers. We need to look at Neolithic populations and contemporary Chalcolithic cultures across India. And of course, the megalithic populations as well. So a lot of the focus has been on Acheulean, for example, or Homo sapiens, or Harappans. So we need to make sure that our research is more balanced and all of these cultures receive equal attention. So solutions through quaternary studies, this is the final slide, I think. We need to locate more early Pleistocene context south of the Shivalik Hills. This might require systematic targets. We need to go back to the known sites and the new sites and apply new dating methods. We need to get dates from these sites. Without dates, we cannot say much. We need to target specific fossil surveys and paleolithic surveys to fill geographic gaps. And this is especially suggested for PhD students and recent postdocs who are starting their own projects. They can actually contribute in a major way by filling these geographic gaps. Instead of going back to known areas and working on known sites, they can make sure that they're going for completely unsurveyed areas and find new sites for the first time. Of course, another way to approach it is focus on that are going to be destroyed. So you can do salvage archaeology also. We need to reconstruct paleo environments at a lot of these sites using different proxies and not just animal fossils or sediments, but as much as possible. We need to compare South Asian evidence with surrounding regions, including Iran, Afghanistan, Central Asia, Southeast Asia. And we need to better link the environmental conditions with specific technological change. This has not been done very clearly yet. We have things scattered. Studies are there, but nothing is linkable. The resolution is not high enough. And we need to date the fossils directly. Whether it's directly or indirectly, it depends on site to site. But if it's possible by C14 or AMS, we need to do this rapidly. And we need to train paleoanthropology students in quaternary methods and techniques, and also paleoscientists focusing on paleontological issues, as I described here. A lot of times I notice the geologists are working separately, and the archaeologists are working separately, but very rarely do you have them working together to solve common problems. So this is just an outline of what can be done in the future by young researchers as well as experienced researchers. And finally, preservation of key sites and contexts need to be done, including the site of Atnora, where the only known non-Homo sapien fossils is found, and numerous quaternary type sections across Pan-India. So we need to understand how we can do this. We need to discuss it and find some strategies. Thank you for your attention, and I can try to answer some questions if you have time.
Yes, sir. Thank you so much for your insightful and comprehensive talk. And as you said, we need to get together both archaeologists and geologists, and hopefully the Association of Quaternary Research could serve as a conduit for the same. Getting to the questions, let's start off with another Parth. Mr. Parth Shah asked, what were the windows of opportunity that made them take these specific routes of dispersal?
We don't know actually. See, for the African evidence, we have a clear indication that they took routes according to, for example, if you look at the Milankovitch hypothesis, there were specific time periods in the past when there was windows of opportunity based on sea level fluctuations. So whenever sea levels were low, we have these routes from, for example, from Morocco and Spain. Then we have from Djibouti to Yemen. We have Bab al-Mandab Strait over there. So we have these areas with very shallow zones which were exposed as dispersal routes whenever sea levels declined. But for India, we don't have this evidence. Because the one problem is because a lot of these sites are now underwater, especially in coastal zones.
Interesting. Let's go to the YouTube chat. Dr. Chauhan is asking, Dr. Naveen Chauhan is asking, why is it that fossils are preserved in Indonesia, which has a wetter climate, but not in India?
I would not say that I would not compare the Southeast Asian evidence with the Indian evidence. First of all, the habitats are totally different. The fauna is totally different. The research history is also totally different. And I would say that I think the rainfall and other environmental parameters are possibly affecting the geochemistry of the soils. That also we have to keep in mind. For example, a lot of the fauna in Southeast Asia are basically bone beds or accumulations in gravels. But in some cases in India, they're coming from fine sediments as well. So we need to understand exactly whether they're really coming from human environments or arid environments. That is not clear because the majority of the fossil sites seem to be in secondary context. So we can't pinpoint the environment in which the fauna is found.
And going back, you spoke about how changing coastlines and sea levels. We have a question by Mr. Anil Kumar, who wants to know how do we look at these coastal areas and address these changes that have probably happened, and how do we account for, the loss of the evidence along these coastal routes?
The easier way is to look at coastal zones that are accessible. Like, for example, a lot of areas in Gujarat, Andhra Pradesh, Tamil Nadu are accessible and still preserve paleo shorelines. So we do have evidence of some of the earlier shorelines. We don't know what MIS stage they belong to because of lack of dates, but we can try to get a rough age if any archaeology is associated with that. But the more difficult way is actually look at submerged evidence, which they're doing successfully in many other parts of the old world. That depends on what the water situation is like. Maybe in times of low tide, for example, certain sites might be accessible and might be preserved. And even fossil accumulation, stone tools, if they're stratified, if they're exposed by erosion, for example, that were submerged earlier but are exposed now. So it might be worthwhile to check certain zones which are underwater but in a calm environment and easily approachable for underwater archaeology.
That's interesting. So sticking along the coasts, we have a question by Mr. Ramanand Yadav, who wants to know if there's any evidence towards migrations for Andaman and Nicobar Islands and also changes in that area since the last 100,000 years.
We have evidence of migrations, of course. We have evidence of Homo sapiens reaching that zone because we have the hunter-gatherers there. And based on the genetic evidence, they seem to have been there at least 65,000 years. Now, the question is, how did they reach there? Did they reach there through an archipelago from mainland Asia, maybe island hopping over time? Or did they have boats and they sailed all the way to Andamans? Or is it possible? Now, keep in mind that they could have arrived in the Andaman zone very late, but they could have arrived in the mainland zone very early. So the mutation rates of the genetics can be misleading for isolated populations. We cannot rely on the genetics to talk about arrival onto Andaman Islands, but we can talk about the general arrival in the region, even if it's mainland.
Interesting. Just let's move in a little bit more closer towards the Holocene. This regards the YTT. Again, Mr. Ramanand Yadav is asking what is the spatial extent of the Toba ash, especially towards the west, and what is its record from Madagascar and East Africa. And to add on to that, Mr. Saurav Mukhopadhyay is asking what is the possibility of using the YTT as a stratigraphic index, considering that it is mostly in primary and also in secondary context, and recent work by Biswas et al. Have showed that there is elements of fluvial processes that have reworked this deposit. So how do we look at the Toba ash question?
Okay, so there's first of all, the first part of the question, we have Toba ash coming from East Africa, I think Lake Malawi, and we also have Toba ash coming from South Africa. Of course, that's because of airborne travel. I mean, it got blown over there from Southeast Asia and got deposited, and they were able to identify it geochemically. Now, that far away from Toba, there's probably no impact or minimal impact on those populations, but geologically it was deposited. Now, if you look at the Toba ash as a marker, first of all, I think we cannot use it even as a marker for the YTT tephra, because most of it is coming from secondary context. Just like Biswas et al. Proved, the sites like Morgaon and Mori, in other sites, they're showing that this tephra is younger than previously thought. But there's another problem also. Some researchers have also hypothesized that this tephra is older. So there were other eruptions of Toba, and those tephras are labeled as MTT and OTT. So it's possible that some tephras might be pre-YTT, but we cannot distinguish them because geochemically they're very similar. Geochemical fingerprinting is not going to help us actually identify that. So our best reliable method is date the context and see if it's primary YTT or secondary YTT. Now, the problem is if it's younger than 74,000, then we won't know whether it's YTT, MTT, or OTT.
And the last question is by Mr. Rajiv Nigam, who wants to know if you have any particular or specific advice for people working within the Holocene.
Yes, my advice, as I said in my slides, I recommend that you, depending on your expertise, you collaborate with geologists if you're an archaeologist, or if you're a geologist, I suggest you collaborate with archaeologists and try to understand at a regional level what's happening with other cultures besides the Harappans. So Harappan has received a lot of attention, but contemporary Holocene cultures have not received that much attention. And then try to explain why is there absence of certain technologies in some zones, like the missing Neolithic, for example. Why is there transitions are uneven? Why are certain tool types changing rapidly in some zones and changing very slowly in other zones? What is the interaction or what is the relationship between hunter-gatherers and farmers? So a lot of these questions can be answered about socio-cultural aspects, about environmental aspects, about subsistence strategies based on environmental reconstructions at a lot of these sites.
Wonderful. Thank you so much, sir. I would like to extend my thanks to the Association of Quaternary Research, as well as the entire ECR team for handling and making this event happen. I'd like to thank you again for accepting the invite and your gracing us with your talk. I'd also like to extend my thanks to everybody who participated here today. We have another talk coming up on Monday. You could find out the details on our WhatsApp groups, as well as we've recently launched our Twitter page, that is at AOQR India, where we'll continue to update all of these information. So until next week, I would like to thank everybody here and see you then. Thank you, sir.
Thank you, Akash, and thank you to AOQR and to Benita also for giving me this opportunity to present.
Thank you. So thank you. Disperse and meet next week at 2:30, Monday.
Sure.
Okay, thank you everybody for participating. Bye.